Hello everybody. Today we are going to see a very short introduction to quantum mechanics. This e-content is developed by Dr.S.Veeramani, Assistant Professor of English, Government Arts College, Kulithalai. Definition. What is quantum mechanics? Quantum mechanics is an important branch of physics and which deals with very small particles. It deals with very small entity and very tiny things. And before we take a plunge into what is quantum mechanics, we must understand certain words and their meanings which are related to quantum mechanics. This particular field of study, that is quantum mechanics, is used to study the behavior of elementary particles like up, down, charm, strange, top, bottom, electron, muon, tau, etc. And the particles with the spin that come in half integer multiplies, for instance, plus or minus 1 by 2, plus or minus 3 by 2, plus or minus 5 by 2, etc. These are known as fermions. The particles with the spin in integer multiplies, for instance, 0, plus or minus 1, plus or minus 2, etc. These particles with the spins in integer multiples are called bosons. Yes, on this slide we can see the classification of quantum mechanics. In 1924, Max Born, he was the first person who used this term quantum mechanics in his paper, that is Ger Quantum Mécanique. This phrase quantum mechanics was collectively coined by Max Born, Werner Heisenberg and Wolfgang Pauli at the University of Göttingen in 1920s. This quantum mechanics is mainly divided into two. Number one is wave mechanics. Number two is matrix mechanics. What is wave mechanics? Wave mechanics is to describe the behavior of the fundamental particles or objects as wave-like properties. Matrix mechanics is formulated by Werner Heisenberg, Max Born, and Pascal Jordan in 1925. The uses of quantum theory. Number one is to measure precise time in atomic clocks. Number two, which is used to monitor the frequency of a specific radiation in the electron jumps in energy level. On this slide, we see Pauli's exclusion principle. Wolfgang Pauli, he is an Austrian physicist, and he announced his principle, that is exclusion principle, and its description is no two electrons occupy the same state of a quantum. On the right side, I have given you the picture for the Pauli's exclusion principle, bosons and fermions. In fermions, the Pauli's exclusion principle is accepted. Therefore, two electrons cannot occupy the same quantum state. Whereas in bosons, the Pauli's exclusion principle is not accepted. Therefore, two electrons can occupy the same state of quantum. On this slide, we can have some words knowledge and their meanings which are related to quantum. Number one is quantum is a singular noun which means a little amount. Number two, quanta is a plural form that means also a little amount. Number three, quantal. Quantal is an adjective form. It is related to quantum. Number four, quantize. is a verb, which means to convey with quantum theory. Number 5, quantumization. It is a noun, which means the process of making quantum. Number 6, quantum chromodynamics, which means the elementary particles are strongly interacted and protons and neutrons are interacted to form a nucleus. It is an analogy to visual color. It is not that particles are colored. Number 7, quantum efficiency. Quantum efficiency, which means in a specified wavelength, radiation is applied. The radiation is released from a number of electrons released that are also called quantum yield. Number 8, quantum electrodynamics. The electromagnetic interactions are taken place with relation to relativistic. Number 9, the last one is quantum field theory. The quantum field theory, which means fundamental particles and their interactions on the whole, is called quantum field theory. Now we can see what is quantum in physics. The interaction of physical properties with minimum amount is called quantum physics. It is a very basic for the formation of a quantum theory in physics. The quantum can be considered as excitation to the fields or waves. Here we find that electromagnetic field and gravitational field. In the electromagnetic field, photon is the quantum. In the gravitational field, graviton is the quantum. So, photon and graviton are quanta in their respective fields. Yes, this is the picture for photons. On the left side, the number 1. The picture number 1 is the example for the photons. Number 2 is example for the electromagnetic waves. Yes, we can see the scientist of quantum mechanics and his theory and description of it. The scientist Max Planck, his lifespan is 1858 to 1947, and his famous theory is the emission of black body radiation from hot bodies. Its description is energy is emitted in quanta. The emitted energy in quantum has energy which is an equaling to h nu. Here h is Planck constant. V stands for frequency of the radiation. This is what we call the concept of discreteness while an interaction taking place between matter and radiation. There is a paradigm shift. Because of this theory, it replaces classical mechanics and Maxwell's electromagnetic theory. As another theory, we can see that non-relativistic quantum theory. Its description is particles are neither destroyed nor created. Particles move slowly with respect to the speed of light, and particles have mass and do not change with velocity. Here V stands for velocity. Velocity is the vector quantity and speed is for the scalar quantity. And the paradigm shift of this particular theory is these hypotheses are applied to nuclear physics. Yes, another theory is relativistic quantum theory. The description of relativistic quantum theory is particles have zero rest mass, or particles travel at the speed of light, or particles travel near the speed of light. Yes, mass varies with respect to the velocity. This is the principle we can have that E is called m0c squared. So mass varies with respect to the velocity. And on this slide, we can see two important scientists of quantum physics, and their theories are given, and the description of their theories are also given. Number one is Werner Heisenberg. His lifespan is 1901 to 76. His famous theory is called uncertainty principle. It was demonstrated in 1927, and it is called indeterminism. The description of uncertainty principle or indeterminism is not able to measure the particle's position and momentum accurately at simultaneously. So that is the description of uncertainty principle or indeterminism. And the second one is Louis de Broglie, the Broglie's wavelength, which means electromagnetic waves can be treated as particles. The electromagnetic waves are photons. According to this theory, particles can behave like waves. It is to bring out wave-particle duality. It is to bring out wave-particle duality. For this development, Schrodinger's equation is used. It is also called wave mechanics. These are the references that I have consulted for my presentation. Actually, this presentation is out of my own interest, and what I have understood about quantum mechanics, I have included in this presentation. So, thank you very much for watching this video on quantum mechanics.